Hi. What I'd like to talk to you about now is fitting an equation to exponential data. So first off, if we suspect our data is exponential, then our equation is going to look like this: y equals a times b to the x. So I have some sample data for you. Data that goes through the point 0, 3. The next point is 1, about 5.5. After that, we got 2, 12.1. And after that, we've got 3, 25.7. And then lastly, we have 4, 47.3. So almost 50. Okay. So when you first look at a set of data, you might say to yourself, okay, what kind of equation models this well? At this point in your mathematical careers, you may not have seen that many different kinds of functions. You've seen linear functions, things that look like straight lines. And then in your Algebra 2 course that preceded your pre-calc course, you've seen some exponential functions. Exponential functions usually have a nice curve to them like that. And what you'll notice is if you were to consider going from point to point, so look at this first point, you have to go up a little bit and over 1. Here you go up a little bit more over 1, up even more over 1. So we can definitely say that our slopes are not constant. So maybe an exponential function will model this data well. The goal of this lesson is to show you how to take some data points and come up with some possible equations for those data points. This is not an exponential regression. What we're going to do is we're going to pick 2 points on the graph and build an equation. So I'm going to take, for example, maybe I'll take the point 0, 3 and some other point on the graph. Maybe I'll pick the point right next to it, 1, 5.5. Okay, so what we're going to do is we're going to build an exponential equation that goes through these 2 points, and we'll see how well it does in estimating the other points, and then maybe we'll pick 2 different points and build another exponential equation. So here's how you would do it. I would start with this point here, 0, 3, especially if I have an x value of 0, and here's why. If you sub it into our equation, y equals ab to the x, you get y equals, sorry, not y equals, you get 3 equals ab to the 0. Well, b to the 0 is 1, so you get 3 equals a. Well, now you're ready. Take that point along with this x value and y value and sub it again. So you get 5.5 equals 3 times b to the first. Well, b to the first is just b. So b equals 5.5 divided by 3. We'll go to our calculator. 5.5 divided by 3 gives us 1.833. So that means a good estimate for what a good exponential equation might be 3 times 1.833 to the x. Now if we want, what we could do is go back to the calculator, graph that equation, and see how well it goes through or near our other points. So 3 times open 1.833 close to the x. Hit enter. As far as a good window, we look back at what we originally drew. When we started this problem, we were like 0 to 5 on the x-axis, looked like 0 to 50 on the y-axis. So that's what I'm going to do here. I'm going to go to Window, 0, 5, y max, I'll make that 50, and we'll take a look at the graph. And it certainly has the curve. It looks like the green picture I drew on the other one. I'm going to type in some of the points and see how we did. I'm going to hit trace. I'm going to do 2 enter. 2 enter gives me 10. That's a little lower than 12. 3 enter gives me 18. That's kind of far away from 25. And 4 enter gives me 33.86, which is significantly lower than 47.3. In the next video, what we're going to do is we're going to start with the same set of data points, except instead of using 0, 3, and 1, 5.5, I might try using, for example, 1, 5.5, and 4, 47.3. See you soon.